Hi, I'm going to show you how to answer a fundamental particles question or a particle physics question from the new AS Unit 1. These are pretty standard questions. We see the same sort of thing coming up, and once you get into the habit of doing them, once you see the patterns, you can rely on the exam board to usually do something very similar, as they're testing usually the same bits of key knowledge. So today we're trying to look at the positron and the up quark. We're looking for similarities and differences. We've been told that they are positively charged, which makes them the same. But what are they, or why are they different? So state two differences. So the first thing I'm going to say is that this positron here is a lepton. I'm just going to say positron is a lepton. The quark isn't. I mean, let's not get too colourful with our language. And then I've got another difference would be that the charge of E plus is +1, but U for my up quark is +2/3. Just noticed that I've spelt this wrong up here. When two protons collide with enough kinetic energy, the following interaction can occur. So here is a particle interaction. It's not told me what this particle X is, but I think they might ask me to work it out as I go through the next bit of the question. It says, without worrying about quarks, give two reasons based on conservation laws why X cannot be a neutrino or an antineutrino. Now, I need to remember a little bit about neutrinos and antineutrinos, and they carry a lepton number of 1 or -1. Now, if I have a look on this side here, I've got no leptons. Both of these are protons, so there's no leptons here. So there's a lepton number of 0 on this side. And if I look at this one here, I've got a proton and a neutron. They've got lepton numbers of 0. So whatever this particle X is here, if it's either a neutrino or an antineutrino, it must have a lepton number, and that would unbalance these two sides of the equation. So no lepton to start. Therefore, number must remain 0, so no neutrinos. And then the other thing I'm going to think of is I've got a charge, haven't I? So this is +1 and this is +1. This one is +1 and this one is 0. So that one there must have a charge of +1. Now neutrinos have no charge. So when we say X must be +1 charge and neutrinos have no charge. So if I'm conserving the numbers, I need to obviously put them in so show I know what they are. So a proton is an up, up, down. So up, down, and that's going to another proton. So that's up, up, down. A neutron, up, down, down. And this unknown particle X all the way down here. Just going to slide it up now, I've got that written down. So I'm just going to cross these ones out because there's no change in those quarks there. So it's only these here I need to worry about. So if I've got up, up, down here, I'm missing an up. So that up must be in this particle here. Now, I'm hedging my bets that this is a meson because otherwise I can't balance the baryon number from that equation at the top. So I think if I'm conserving it, then that one must be an anti-down. And that would actually make that a pi positive. Now if this one's my neutron, then that must be up, down, down. So it's asking me to work out what this thing must be. I know it must be a meson. I know that there must be an up quark in it. And I know in order to balance that, I must have an anti-meson, and I'm going for anti-down on this one. Suggest what force is responsible. Well, I know this is the strong force. And how do I know that? Well, it's got, there's no lepton or neutrino involvement. So actually, I don't know why it is the strong force. I know why it isn't the other ones, and that's the That's the way I'm solving that particular problem. So the next bit is giving me a different one, and this one is relatively straightforward. It should again come out, but you need to know your stuff. So here I've got two protons colliding. They're making this unknown particle here. So I need to obviously give a reason for why I think this is this here. Now here I have a lepton number of 0 and 0. Here I have 0 and 0 and an unknown and a lepton number of 1. So this must have a lepton number of -1. So this is this must be a positron. So Y is a positron. And how do I know it's a positron? Because it must have a lepton number of -1, and the positron does have a lepton number of -1. And how do I know it's a positron and maybe not an anti-muon or something? Well, you see the E here in this VE, in this neutrino here. That's telling me it's an electron neutrino, so it belongs to the electron, well, or the positron in this case, because it has a special name. So Y is a positron because it will balance lepton number, and it's electron neutrino. That's possibly a little bit more than we needed in there, but there's no harm in showing we know what we're talking about. And then state whether or not this one is more or less likely than the other. Now this is more likely because this is a weak interaction. And that means that the usual time we have for this sort of interaction to occur is longer than for a strong force, so it's more likely to occur. So I'm going to say weak interaction, time is longer, therefore likelihood greater. Now that one's pretty nasty there on the end. But if I just flip back over again, you can see the rough one I did underneath, just to practice. You can see that this one's question 7. So this is coming out of the very back of the exam paper, so it's not surprising it's a little bit more challenging